Welcome to week 5. In this week we will finish doing our rain setup. We'll work a bit the collisions and also we'll do an event when the particles hit the ground, make them split. Also in this same week we'll do these effects. That it's a trail with some nice turbulence. We will see how a color attribute works, and we will prepare for render this same shot. We'll add some volumetric lights just to see how they work and get some nice final result for our particles. So okay, here I open the scene that we left from last week. Let's save it as week 5 particle basis English 1. Okay, what I left from last class was this box emitter. Just get rid of that. And okay, let's get inside our particle setup. What we've done, we add a collider, we have our particle behavior, and we have our solver. We saw last time that if we have this color hit turned on, we'll see how each particle, as soon as it hits the floor, changes color, and now response is unchanged, so nothing will happen. It will collide and stay right there. The important thing about using Houdini is that you can group and make groups from different events. Here we have the emission, as we saw last time. It's the stream source first input, and what we can do now is save in a new group our particle collision. So this means that if we turn on this option and write particle collide, hit enter. Now we see, if we rewind our scene, load a bit of cache, and wait for some particles to collide. Let's middle click button here, and we'll see that now we have 81 particles that are part of this group. So nice. I'm saving and creating a new group. Let's say I want to create a new particle system from these particles. First of all, I want the response to make them die. I don't want any particles as they hit the ground. But I will still get a particle collision group. Right now it's 0 because this creation only works for one frame. That is the exact moment that it's collide, and the particle is dead, so we have 0 particles here. So let's add a new pop node called it was called pop replicate. And if we add it to our tree, let's first just to make some separation, add different colors, because we have 2 emissions right now. No, I don't like these colors. I'm from River Plate. Okay. Pop replicate 1. Now we see here in the attribute editor that we have a couple of options, very similar to our source input. We have a birth, we have a number of particles emit per second, we have our life expectancy, we have our shape. As soon as each particle hits, let's see what happens. It will be much more clear. Now what's going on? We see a big emission right here. It seems that every particle is replicated and generated a radius just from scratch. We don't want this. So just turn on the group and select the particle collide. I only want to have emission for the particles inside this group. Okay. Now we see a much better result. But there's a problem. The particles area are too big. This is because the shape. The shape is an initial shape that these particles will have. From 0 to 1, they will add a random position. Let's get this scale a bit lower. Now we see how this radius made smaller. But we don't want just to be there one frame. We want to add some animation, go up a bit, spread, and die again. We can also add some noise to this position. Just you can play around with this. You will see how the position change. And there's also an attribute value, very similar to our first input. This works exactly the same way. It will inherit attributes from our input connection. We don't want this. We want to set manually initial velocity. Okay, and this part is disabled. Just let's to make sure nothing is bothering the LED, the star. So we have a velocity in X, Y, and Z, and a variation. This is a random applied to this. So let's add some small values. So we'll have a variation over this, and over this of 1 in each case. Okay, now we see the particles collide, spread, but they seem not to have any gravity. There's another way to add a global gravity to our scene. If we hit Tab here and type gravity, we have a gravity force. You will notice this is not a pop force or pop wind, it's a gravity field. This means it has to be plugged after our pop solver, and this same field can be used for fluids, for water simulation, for rigid bodies. You can use this field everywhere. This doesn't happen with this pop wind that only has to be plugged and used in this part of the node hierarchy. Okay, now we have our new gravity set by default, so probably we have to change. Okay, here we have a more interesting effect. That's not working that bad. So well, feel free to play around with the pop replicate, make some variations over the velocity, over the shape, play around also with gravity. And okay, if you hit middle click button, we'll see a pop collision, the new pop replicate particles, and the first input. So we have 3 groups that we can play around, modify, emit, do whatever we want. Once we are happy with this, let's do some test over render. But let's see first, let's suppose that we want to add different rain levels, different areas. For example, foreground pass where we don't want these collisions on the floor. We want a faster and more dynamic, or maybe add more particles when they fall, but we don't want particles when they collide. Or probably we want to add a pass very far away with bigger emitter, for example. That's easy. The best way to do that we can add a merge node down here, and we can Ctrl+C, Ctrl+V to copy and paste a new range system. If you have everything selected and want to do a new connection, it will connect everything to a new position, so we only want the last output. Okay, so now if we template this, we have 2 emitters, one over the other one. Let's first move this emitter a bit higher. And let's do the same for this. Let's say 8 or 10. We can make it a bit bigger, the one that collides. And I want this to be a foreground pass. So let's move it a bit this way. Increase the size. But let's say that for this foreground pass, for example, let's put the camera this way. So from this system we don't see collisions on the floor. We will see them from the other system. So just get into the particle system, and it's as easy as bypassing this node. So right now we have a rain in the foreground, in which we can add even more particles. Okay, we have a heavier rain in the foreground. And we have our second particle system. Just to earn some memory, to get things faster, it's always good to work in different levels. Also, you can cache them later on and make a render separately each pass. Just to get collisions everywhere, let's make this guy bigger. Okay, and remember, as this grid is infinite, we will have collisions also out of it. So nice. Let's save this. Once we are glad with our result, remember we delete the primitives, just to delete the floor geometry. And I made a copy drops where I plug a sphere, not big deal. Let's create a camera based on this view and move it just to get inside the rain. And now let's add we can add a shader to this. We already know how to do it. It's the same shader of the drop that we've made the previous week. So let's add a class shader, or you can build it your own, it's the same. And I want these drops to have that shader. Let's get that connected. Okay, that's working. Now I would like to add a light, as we don't have one in our scene. I like to use a lot this area light because of its fall off and softness. You will get nice results. You have to set up a bit high the intensity because of the fall off. As soon as you get far from the light, it will lose intensity. So for now, let's keep the size of this area light 4, and let's see what happens if we go have intensity in 100. Let's move again to our camera view. Let's get things clean. This is our render camera. This is our area light. Let's go to our render view, select our camera, and let's leave this as it is so it creates a render output for the first time. Let's turn off this preview. Okay, we have our drops. There are spheres, no big deal, but okay, we see that they don't look as such. What is missing? Motion blur is the most important thing about the rain. There are many guys that do some streaks here. Yeah, it could look faster or whatever, but I prefer to do them with motion blur to get more realism, and that's what happens in real life. Drops are spheres, and you see them with a lot of motion blur. So there are a couple of things to do to turn it on and to have into consideration. The first one, inside your ROP, your mantra node, in the output level, you have to turn on inside rendering allow motion blur, but nothing happens. You'll see that everything is in the same exact way. That's because in the object level you have to go to particles, and here inside render sampling there's an option turned off by default, that is geometry velocity blur. Okay, but nothing happened. What's wrong, huh? Geometry velocity blur is turned on, but every time you need to calculate motion blur you need the velocity attribute. Let's see what's going on. So on our copy drops, we hit middle click button, we only see position, and if we hit the previous node we have all the particle attributes included velocity. This is what we need. So your question is, what happened here? Why we didn't transfer or get the same attributes? The copy stamp node had an attribute section where you can turn on use template plot attributes. If you turn that on, now you will see that velocity is passed to this node, and if we middle click button here, we'll see velocity is right now connected and working. So that's good. That's what we wanted to do. Now we have our rain. Just two things to have in mind to get a better render quality of this motion blur. The only way you can do that is inside rendering. You have the sampling options here. You have to put these values a bit higher. Now we have a more soft motion blur. Just remember, the higher values you get in the pixel sample, the render will be much slower. But well, it's very soft right now. Other things that it's bothering a bit is maybe you have some sharp reflections that will make some strange note. You have to go to the material and add some roughness to that. There's also a way to change the amount of motion blur. That it's done inside your camera. Inside your camera you have the options to control motion blur, and later on we'll see that you can control also depth of field. Inside sampling, this shutter time, the lower the shutter time is, the shorter the motion blur you'll get. So let's see 2.5. Yeah, probably it's working a bit better. You can later on play a bit with the shader and see what's your result. But yeah, this is a way of controlling motion blur and getting our drops. Okay, one last thing, just make sure that play around with this, do your own setup at different levels. And what I wanted to show you as last instance, so as you get a better exercise or example, I will show you how to add an image to the background, so you can play better with this setup. Also, as you see, probably this is not the nicest way to show them. You have to light a bit better. You can probably add an HDR, not that intense, probably 0.25, depends on the HDR that you are using, and also add 2 or 3 lights to add something more interesting to the final result. Now I'll show you how to add an image plane or a background image, just by selecting the camera or going here. Inside the view option you have a background image. It's enabled right now, but nothing's there. I left you inside the text an image, a picture. And what you can do from here is lock your camera view, remember that, and probably match a bit the position of the ground. I don't know, you can play around with this. And the important thing about this enabled background image, let's see what's happened. I will render this as it is. Okay, our background image just appeared in our render. This is good for previs, just to see what's going on, just to work integration a bit. That will be fine, but we don't want this on the render. If we hit A for the alpha, it will be you will get some alpha, but it will be pre-multiplied using the background image. So we don't want this because we will get some strange transparency after in comp. So I would like to not show this on the render. So just by going back to the render camera and disable this enable background, you won't have that image, but the advantage of this is that you will see here in your viewport. In case you don't want to see the image in your viewport, just or delete the path, or you can hit this button and you work without that image. Awesome. Let's save this. So you have everything to do a nice rain setup. I will show you also one last. No, we'll see it later on. The last thing to do, you can go to your mantra node. Now you have everything set up. You know how to put your camera here, set a frame rate, and the output. The output is a $heap where you save your file. It will create a render folder, and the sequence will be named with your shot name, your scene name. $S, it will get your mantra node name and frame with 4 digits padded, and EXR format. That's okay. If you are good and glad with this, render to disk. One thing I like to do before doing this is to cache my particles. I will show it in the lesson that is coming after this, the trial. You will learn to do that. But other important thing to have in mind right now is that every time you use simulation, not always you want to show the effects from the beginning, just how it evolves, how it's progress in time. Just want to start using your rain probably from here. So from frame 1 to 40 and 45, it's called what we say a pre-roll. This is a part of the simulation that is not shown, you won't use, but you need it to be done, so as to start rendering from this instance. From every DOP node, you will have a simulation tab, and you have a start frame. A good way to avoid this in render is to start frame earlier frames. You will see start cooking from the frame -50. So if we go to our options, set the starting frame to -50 and get our slider to there, we will see the particle simulation starts and makes it emission from that frame. That's good, because I just want to render from frame 1. So once you are in frame 1, FX is already there, so you don't need to start from render 50. So pre-roll is always important, just have that in mind. Well, I think that we are done with this exercise. Let's move to the next class. Okay, let's continue. Let's save a new scene. Let's call particle turbulence emitter or abstract emitter, as you wish. Just put the name you want. We will start doing these effects from a sphere. So we all know already how to do this. I want to get a polygon with nice frequency. We'll name this As I told you before, the mission is everything on simulation, the more organic and random. You have to be smart and do some nice emission. Emission is the 50% of any simulation. So what I will do next is add a mountain node to add some deformation. I don't want to have too much height, but yes, I would like to animate this value. You can play around with noises and see what you get. Just that I wanted that, just to add some nice noise. Okay, I like that. Let's add some offset to this. We can use $T, that it's dollar time. Difference of dollar frame is that time goes from 0 to 1 per second, and dollar frame goes to 0 to 24 or 25, 30, depends on of your frames per second. So let's use time this time. Okay, we have our nice emission. Let's multiply this by lower values just to get a slower noise. Okay, and instead of doing this, it's annoying if you want to play around with your values and modify. I don't like, because it's the same expression, so I don't like to do this. There's a way to copy and reference later on, paste it and reference later on to this first value. That's easy and it's used a lot. You can copy your parameter and right click button and paste your relative reference. Paste relative reference. What it does, it's easy. You don't need to go any level up, so it's just inside the same node. You call your channel. You can write it this by hand. Channel, and you get your attribute offset X. Where do I get this attribute? Just move over the offset attribute and you'll see the different parameters name, offset X, Y, and Z. So now you see where this comes from and how to do. So now if I modify this value, it will be refreshed on the other two channels. That's great. Okay, now we have our nice deforming sphere. Let's save this. And what's next? I want to add some animation. But it won't be any normal animation. We will do it based on expressions. There's a math function called scene that I will show you right here. This is exactly how your animation curve will look using scene. Scene is a kind of cycle that you can apply. You can modify frequency and amplitude. Frequency is how high this wave will go, and amplitude, how many times it will be repeated per second or per frame. So the way to build this, just write it down because we will use it also a lot. We will type scene, we'll use you will open brackets, and we need a value that change over time. It can be dollar frame or dollar $T. That's are the ones that we know. What we will use, dollar frame. Let's use this time. We have to multiply this by a value that will be the frequency. Let's leave it easy. We close brackets and we multiply again by 1. So 1 is the frequency and 1 is the amplitude. Not big deal. Let's see what's happened. We have an animation. Our object goes in different directions based on a similar curve like this. So okay, let's say I want to modify amplitude. I want not to go far more than 1 unit. So if we set this value down to 0.2, it will move 0.2 units on your grid. Awesome. Let's keep it in 0.1, but I want to move faster. I want to have more cycles in these 240 frames. So let's see what happens if I increase this value. Okay, it goes faster. We can see this in real time just by hitting this real time button. Nice, we have our animation, math animation, in our x-axis. Let's add this. Now let's type it so that you incorporate this. Let's type it again. So sin dollar frame multiplied by our frequency. I don't want the same exact value. I want to change it a bit so that we have a more random movement. Multiply by, I don't remember what was the other value, but it was not 0.75. Let's play this. Okay, and now it goes Y. We can set this value higher. Nice. So one axis is missing. Let's do the same. Sin dollar frame multiplied by our shorter, longer frequency. Let's make it a bit higher and multiply by, let's say, 3. Not that much, probably 1. Okay, now we see that we have animation on all our axes with some math functions that we will use a lot, so it's good for you to know them right now. Okay, so now we are happy with this. Let's save our scene. The last thing I want you to do is to add some normals. Let's add it add the normal attribute. And I want a point bob to add some random to them, just the same thing we did in the rain. So remember, we want the normal and the position. We create a turbulence noise. We map it inside our position. Remember always to change when you work in a 3D space, to change this noise to 3D. And let's now multiply by our normals. and I want this result not to position but to normal and also velocity. One thing that I missed was to change these abnormals 2 points. So now we have our normals. Let's play around with our noise. Probably a bit of roughness, and that's it for now. So what's next? Let's add our particles. Let's emit from this sphere. Let's add a pop network and see what happens to our first playback test. And here's an important thing to teach you. There are two things happening. The first one is that we don't want, for now, to get some inherent velocity. So let's delete this guy, and we will see clear our problem. This is also a very common problem on our emissions. It's that the particles are emitted one per frame. We don't want this. We want a flow, a softness and more organic emission during the subframes. Also, the subframes are all the frames between frames. So a way to add more subframes to a simulation is called the substep. Substepping is what you say inside the dot network node simulation. You see that our substeps are right now at 1. So this means that we have only one calculation, one emission per frame. If we hit play, we'll see, oh, okay, this is not working at all. If we increase our value, the higher the substep power, also the lower the simulation will be. But right now we see that nothing's working. So you might be wondering why. There's a way here in Houdini, just to add where the global animations options are. You have an integer frame values. These are playback options. So right now Houdini says that it will only play on your timeline integer value. So let's turn off this guy and put a float value. If we hit apply and close, now we see in our timeline, if you go one frame forward, we will see that nothing happens in your animation until a certain point. Noise is moving, you'll see your turbulence doing its operation, but not the animation. So what's wrong with this? Something might be wrong in the animation, because if the rest is good and animation not, you can find the solution here, and this is very easy. We are using right now a variable called $frame. $frame is the output of this variable is an integer. 1, 2, 3, 4. That's why we are having animation every one frame. To get a float result for this value, we have to add another F, floating frame instead of frame. So right now our output will be a float and not an integer. Let's see what's happened now. Okay, that's what we want. Animation on every frame. Now we are happy. Let's move this guy back to where it was. If you turn it on, it will reset the original value. Let's turn substep to 1. We won't see any emission, but if we put it in 3, we will see that frame. Let's add a bit more particles so just to see better what's going on. We have 3 emissions on every frame. That's great. If we increase this value, we'll have 5 emissions per frame. That's great, but you have to have in mind that the higher this value, the slower the simulation will be. So you have to get a balance. Probably the first test, do it with not big emissions, because the more particles also you have, the slower the scene will be, and also the more memory consuming. So for now, let's leave this 4. And okay, let's hit play. Nice. We have our particle emission based on our animation. We have a nice abstract pattern. So it's time to play a bit with the turbulence. We also been using this, so your pop wind. Let's make 2 of them. A big turbulence, copy paste, plug, and a small turbulence. Let's first bypass the smaller one just to see what the big one does. Still nothing there. Also, I would reduce a bit the particles because we are having too many. Okay, our particles are moving super crazy, so they need less amplitude. And another thing I like to use when using turbulence is to add a pop drag, so that they lose energy. It's like a damp. They lose energy over time. The higher the value, the more density, the more energy they lose. So we see that now they stick to our turbulence. You can still play around with this, probably make as it's a bigger noise, the turbulence bigger. You can also play with the pulse length. Remember that it's the animation of that turbulence. Also, well, you can play until you get a turbulence setup that you like. And once you're happy with your first emission, let's work the second one. So we said that it's a lower frequency, so let's keep swirl size low. We can also add and see what happened. The pulse length is repeating a bit. The particles are they don't move in a natural way. Okay, once you see a result, let's Save this. Once you see a result that is working, you can increase the amount of particles just to see, have a better idea how those noise work. Okay, that's not that bad. You can play around, you can add also other noise levels, and what I want to do is to add a bit, just a bit of inherent velocity, just to break a bit this first emission. As we have damp or drag force. Okay, that's better. Probably a bit less. Well, and it's, this depends on you. Just look for your behavior and see what works good, what you like best. Yeah, a lot of particles are missing, but the higher this value, the more time it will take to calculate. Okay, once we are happy with this, I want to add some color variations to our particles. There's a node called pop color, and this will add color to all our particles. Right now it's set up as constant, so it will apply a constant color to every single particle. I want to use a ramp, and as you see, ramp has a default value of NH. This normalized age. It will normalize the age of every particle. It doesn't depend if you have a lifetime variation. It will normalize it and add a color from black to white. Right now nothing happens because we don't have the attribute turned on, so we have to go, we have it, but it's pretty high to our emitter, and let's say the expectancy, let's say 4, and add some variation of 0.25. Now we see how our particles change their color based on age. RF to center, and let's color change. Well, as Houdini is a nice guy, you have some presets also here. You can map it by speed. You can map it by height, by age, or normalize age. If you use it by age, it will go from 0 to 1. It doesn't matter how old the particle is. So it's better always to get a normalized age. In this case, I would leave it at speed. And let's add some colors to our particle emission. Let's modify this ramp. Let's get some blue. Okay, and now we see, depending on the velocity of the emission on the particle movement, we have our nice color assigned to it. Okay, now let's say we are happy. We want to prepare this for render. Let's put a camera in an interesting place. Just I like when I put cameras to get some particles in the foreground, some in the background, so we have different levels, and also a nice compositing of these effects. Let's add a new camera, probably put it a bit back. Set it as a render camera. The same as we've done with the rocks. I suggest you to make a file cache. Save your files to disk. You already know how to do this. I'll just save this current frame because it's the one I want to use. Save file and load from disk. Okay, so let's see what's coming if we render this. Okay, no lights in the scene. We have pretty huge particles. The first thing we are going to do is make those scale smaller. We have to create an attribute called scale. We already seen that this controls the particles on each scale, and right now the value is 0. That's because it disappeared, but let's put a low value. Nice. Now we have our particles, everything's rendering. Let's work a bit the lighting. I told you we'll do some volumetric lights. It's a way, there are many ways to do it. The way to do this is to add a geometry. Let's name it environment. And I want to make a box that contains our particle system. Let's turn off the camera, I don't want to lose that. Let's say to 10, so that our camera is inside. Okay, and what we'll do is convert this to VDBs, to volumes, to, let's say to like a kind of fog. No, sorry, not that one. You will use convert it's VDB from polygons. Right now our output is a distance surface, so I want a fog with VDB by density. Right now we see that everything turned on white. This is because density is very high. We can control and multiply the amount of density by adding a node called volume bob. Just it's the version of point bob but for volumes. If we get inside this, we'll see we have plugged already our density in and out. So this is easy. We also have to add a multiplier here. There's a node called multiply constant, so you don't need another value to multiply. You will use the value that Houdini provides. If this value is lower, you will see how density goes down. Okay, we'll play around with this value later. So we have our fog, our particles. I want to add a light. The best light for this is a spotlight. Let's move our camera back a bit. I want to add from a side from the camera. And move the origin. Other thing you can do is once your light is selected, look through selected. Sorry. Go through look through light and select your spot. Remember to have the lock camera on, just to move and have the position you would like to. Once you're glad, let's go back to camera. Probably the angle is a bit wide, so you can control under spotlight your camera angle. Probably put it a bit near and a bit wider. And let's save this just in case and check out what's going on. Well, first instance, our light is extremely low because it also has attenuation, it has a physical decay. And now how see these lines, these are the volumetric lights. What I can see is that the fog intensity is huge. Right now, let's set it down. I also want to make the cone smaller. And also, let's go back to our mantra node and set up a bit our pixel samples. There are also another ways to modify the volume quality. We will see them later. But well, now we won't see that good the shadows because we have small particles and we don't have enough. So just to see and confirm that everything's working, let's increase this value. I think that the light won't pass through because now they are too big. There we should have a better result. Also, if you want to make 100% sure that everything is working good, you can hide this and create a basic sphere as a test object. And make sure the light let's make the light a bit bigger, the cone. Okay. And if we render this, we should get a faster render, and we will see how volumes work. Here you see the shadow ray. So the setup is working good, the light is working good. I suggest you to add more particles to your simulation, to make them small, to find a nice camera angle. Some nice interesting view, and do your own setup. Once you are happy, you can go to a mantra node and render as EXR, and that's it. Everything's working good. Let's finish our render and let's continue next week.